Good evening and welcome again to my science channel. Last time we looked at astronomical units, light years, parsecs and things like that. So this week we go into advance that a bit and we're going to talk about Edwin Hubble. Now in 1929 at Mount Wilson Observatory in Pasadena, California, Edwin Hubble was looking at galaxies and he was analysing the spectral light coming from galaxies. And what he said was that the cosmos was expanding. So if you can imagine the galaxies being currents in some dough for a loaf of currant bread, and when the dough is rising, if you can picture all the currents getting further away from each other and moving outwards, that's what he said is happening in the cosmos. Now, what he was trying to find out was how fast the galaxies were moving away from each other. And he made some observations. And he observed some spectral lines that we talked about briefly last week when we talked about temperature in Kelvin. And a star will emit light at all different frequencies, and we are familiar with that when we see rainbows, because the water droplets are breaking up the light into its spectrum. And as some stars emit light, but the cooler outer atmosphere will actually absorb pieces of light. And when you analyse the spectra coming from there, what you will see is dark lines or Fraunhofer lines in the spectrum. Now what Edwin Hubble noticed was the further the galaxies were away, the more that these lines were shifted towards the red end of the spectrum. Now we knew they were further away because they were fainter. What Edwin tried to work out was a constant. The galaxies were moving away from each other. And there's been a little bit of dispute over the years on the figure. But the figure accepted today is going to be 68 kilometers per second per megaparsec. So for each megaparsec away that the galaxy is, then that's going to increase the velocity that it's moving away by 68 kilometers per second. So let's have a look at a very basic model that I've made to demonstrate this. So if we have a look at our little model, I've got the Earth on a stick, spiral galaxy on a stick, and another spiral galaxy on a stick. And from the Earth, this first spiral galaxy is 3.3 million light years. So that's 1 megaparsec. So what Hubble is saying, that this galaxy here is moving away from the Earth at 68 kilometers per second. Now we've got the second galaxy, which is 3.3 million light years, or 1 parsec, from the second galaxy. So this galaxy is moving away from this one at 68 kilometers per second. Now if we look at the bigger picture, this galaxy is 6.6 million light years, or 2 parsecs, away from the Earth. So that is going at a faster rate away from the Earth than this one, and the speed is 136 kilometers per second. So it's double it because it's 2 parsecs and not 1 parsec. We know now that Andromeda M31 is 2.5 million light years away, and we converted that into megaparsecs last week, which was 0.75. The challenge for you now is to try and work out how fast Andromeda is receding away from the Earth, and then I'll go over this, but have a little go at it first. Using the information that Hubble had, he developed an equation which said HO, which is the Hubble constant of 68 kilometers per second per megaparsec, V, which is the galaxy's radial outward velocity, so that's the speed it's moving outwards, divided by D, which is the distance of the galaxy away from the reference object. So say for instance Andromeda from Earth. So we know that HO, which is the Hubble constant, is equal to V over D, but we want V. So to get V on its own, we need to get D onto the other side of the equation. And with the laws of algebra, it's V divided by D. We have to do the opposite to move it. So that's multiply. So if we say H 4 times d will equal the velocity. So that's the Hubble constant times the distance will equal the velocity. Now we worked out last week that the distance Andromeda was away from us was 0.75 megaparsecs. So with that in mind, we can say the Hubble constant, which is 68 kilometers per second per megaparsec, times 0.75 is equal to 51.51 kilometers per second. So with this calculation, what it's saying is that Andromeda is moving away from us at 51.51 kilometers every second. Well, I hope you enjoyed that. That's the second look into astronomy that I put together for you. If there are any questions, please comment and like, subscribe. As I say, I hope you enjoyed it, and I'll see you soon. Thank you very much. Good night. Stay safe.